The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody, from Silicon Valley in California. I'm Donald O'Shea of the FIDO Alliance, and welcome to the FIDO U2F webinar. The presenter today is Alexei Czeskis of Google. And without further ado, I'll hand over to him just to let you know that we will take questions if we technically can, and we'll use the chat window for that. We won't have any voice questions. Alexei, please go ahead.
Hi everybody. This is my first time using this particular piece of software, so if there's a couple of glitches, I apologize ahead of time. I realize that for some of you it might be morning, for others it's a day, and for some of you it's probably evening. Thank you all for joining regardless. And as Donald said, my name is Alexei and I write software at Google. Today I'll be taking you through the U2F, the Universal Second Factor. Some of you are just starting to learn about U2F, and others may already be well versed in U2F terminology and principles, and probably can't wait to see some code and maybe even start coding. Hopefully, you'll all walk away happy from this presentation, as it should cover all of these cases. So let's get started. Today, we largely live in a world where users get authenticated to websites by passwords. Unfortunately, passwords are bearer tokens, and as with all bearer tokens, they're subject to lots of attacks. For example, users reuse passwords across websites, and you can't blame them. There's a big cognitive burden associated with remembering lots of complicated, unique passwords. But unfortunately, this means that attackers can compromise weaker sites and use credentials found there to compromise accounts on stronger sites. So for example, if a user has an account on bank.com, that account is only as strong as the weakest site on which the user reuses the same password. But it turns out the attacker's job is often a lot easier. Users will simply give up their passwords to attackers. Attackers just have to make a website that looks something like a legitimate site. For example, gmail.com, right? Something that looks very similar, maybe that is vulnerable to a typo. And this, of course, is called phishing. And in some cases, malware can also grab passwords from users via keylogging. And the industry has not stood idly by. Many of the people in the security industry have realized that a password is no longer enough to authenticate a user. Towards this end, the state-of-the-art solution nowadays is one-time codes. And this can either be delivered through an SMS to a user's phone or maybe shown by a dedicated device. But unfortunately, all of these have non-trivial downsides. For example, in the case of SMS, there are coverage issues. An SMS might not be delivered to a handset, and the user might be locked out. There might be a delay. There might be a cost to the user. SMSs are not free for everyone. As far as devices go, they have the unfortunate nature of being one per site. So if 5 of the websites that a user uses, each supports one-time codes, that means that the user will likely have 5 dedicated devices that they will always have to carry with them, and that's unfortunate. These standalone devices are expensive, and sometimes they're also fragile. The user experience in all of these cases is not particularly nice either. The user has to take a code, look at it, and then manually copy it onto the screen before the code changes perhaps to another code. And users found this frustrating. And finally, at the end of the day, all of these cases are still phishable. The user or the attacker can just ask the user to enter their current one-time code and then replay that to the legitimate website. And this is where U2F comes in, the universal second factor. The universal second factor is designed to be one device, which the user can use across many services. It's designed to be easy to use. The user just inserts it into their USB drive and touches it. The universal second factor has been designed to resist phishing and many other attacks. It's designed to be safe. Under the hood, The universal second factor uses standard public key cryptography. During the setup process, the user's device mints a new key pair and introduces the server to the public key of that key pair. During the login phase, the server asks the token to sign some data, a cryptographic challenge to verify the user. This is a textbook challenge response protocol, and it allows the user to reuse the same token across many sites safely and securely. Again, one device, many services. Much thought has gone into the design of the U2F device to make it very friendly to consumers. It's privacy preserving. It has no site-specific keys. In fact, the public-private key pairs are segregated by origin and has no unique ID for the device. That is, if you happen to lose one of these devices in the parking lot and somebody picks it up, they will have no idea who it belongs to. The U2F device is designed to be secure, designed to be not vulnerable to phishing, not vulnerable to man-in-the-middle attacks, and not vulnerable to several other attacks as well. It's a device that both the server and the user can trust. Inherent in the design of the U2F device is this concept of attestation. You'll be able to tell who made this device. It's pragmatic. These devices are already affordable today, and they will become only cheaper in the future. And they're really fast to use. You just insert it and press a button. If this sounds like a smart card to you, well, it is. It's a smart card, but it's been redesigned from the ground up to make sense in a consumer web. All right, so that's enough talking. Let me show you a demo here. And I realize that all of you can see my full desktop. That's okay. All right, so I will demonstrate logging into my personal Gmail account. Here's my username. I've pre-typed my password. It's kind of long. I didn't want to have you go through watching that. So if I hit sign in and everything works, you'll see that the website is asking me to insert and touch my security key. My security key is already in my USB drive, and here I am pressing it right now. And there we go. I'm logged in. This is my actual Gmail account. Great. So a couple notes. First of all, that was really fast. I don't know if there was a delay with this particular software, but for me, it took just a couple of seconds. Also, my U2F device started blinking, letting me know that I needed to touch it. Unfortunately, you were not able to see this, but I guarantee you that that happened. And in fact, this is not just available for me, it's available for all consumers. Google launched this, I forget how long ago, but several weeks ago, I guess. And you can go ahead and enable this for your account if you so desire. All right, so what happened underneath the hood? Let's take a look. First, I typed in my password, and this password was sent to the server just as before. And as before, this was vulnerable to all the attacks that I mentioned. However, after that, I touched my U2F device, and my browser sent a proof that I was actually here, a cryptographic proof, to the server. Now, had this proof gone to a phisher, it would have been useless. A phisher could not take this proof and then send it onto the server. And that's, again, because the nature of this proof binds it to a particular domain. Had I sent this proof to a man-in-the-middle attacker that was intercepting my network traffic and pretending to be the server, even if it had the legitimate server public or certificate, TLS certificate, it still would have not been able to take this proof and apply it to the server and have the server accept this proof. And again, this is because of the inherent design of the U2F protocol. All right, so let's take a small peek inside what was in that proof. The proof has several things. First, it says, I promise that the user was here. The U2F protocol says that the token will never, ever send a proof back unless it was able to ascertain the user presence. In this particular token that I was using, this was done by a capacitive touch sensor. The proof also says that the server challenge was a particular challenge. This was something that the server had generated previously and sent off to the token. It says that the origin for which this proof is meant is accounts.google.com or any other origin. And it has a view of the TLS connection. It has a fingerprint of the TLS connection which cannot be forged. And then all of this is signed with a key that is stored in the token, and the public key of which is known by the server. All right, I'm going to check and see if any questions have arrived before I continue. Okay, it appears that there haven't been any questions, so I'll go ahead and continue. But of course, if something is not clear, feel free to ask questions, and Donald will forward that on to me. All right. The U2F protocol consists of just two operations: registration, where the token introduces the relying party, the server, to a public key, and authentication, where the relying party verifies that the token possesses a corresponding private key to the public key which was previously registered. Both operations consist of just 3 steps. 1, setup. In the setup phase, the browser, in FIDO terminology, the FIDO client, gets a fresh challenge and prepares a request for the U2F token. In FIDO terminology, a U2F token is called an authenticator. In the processing phase, that's step 2, the client sends the request to the authenticator, and the authenticator performs a cryptographic operation and sends the response back to the client. And finally, in step 3, the client transmits the token's response along with some other data necessary to verify the response onto the relying party. A correct registration response will cause the relying party to register a new public key for a user, and the correct authentication response will prove to the relying party that the authenticator was indeed present and touched, and will then allow a login in most cases. FIDO only standardizes step 2, that's processing, in the slide, as steps 1 and 3 are between the relying party and itself. Okay, so now let's take a look at the registration and authentication one by one. This image shows a bunch of arrows, but it describes to you the registration protocol. It begins with the relying party generating a challenge and sending the challenge and an application ID, here denoted A, to the FIDO browser or the FIDO client. And I'll show what the application ID is in just a minute. But it's a string that identifies the relying party as an entity and not just as an origin. In fact, I might just as well show this now. Let me find the right page here. Is it this one? Nope. This one? Oh, sorry. I think it's this. There we go. So this is the application ID for Google. It shows you all of the origins from which we will attempt to perform a registration operation or an authentication operation. So all of these origins map to the entity that is Google. All right, and this string up here, this URL, is the application ID. Okay, so the relying party sends the challenge and an application ID, a URL, which then has a JSON object which represents all of the origins that represent this relying party onto the FIDO client, the browser. The browser verifies that indeed this origin is part of this of the application ID, and then constructs a request object for the U2F token. That request object contains the challenge that was sent by the relying party, the origin that the FIDO client, the browser, saw, the channel ID, that's the view of the TLS connection, and the application ID. Now, we denoted a bunch of this here as C. This is called client data. So the application challenge and the client data is sent over to the U2F token. The U2F token then generates a public key, a private key pair, and a key handle, and then produces a response. The response contains the public key that it generated, the key handle, an attestation certificate, which identifies where this U2F token came from, who made it, and so on and so forth, and a signature S over the application ID, the client data, the public key, and the key handle. The FIDO client then takes all this and forwards it on to the relying party. You'll notice that the signature is there, which came directly from the token. The attestation certificate is there, again, which came from the token. The key handle and the public key came from the token. And then this client data C, which did not come from the token, but it's the challenge that the browser previously had sent on to the token. And this is done so that in case there's any kind of encoding differences, you'll see that the C is actually encoded as a JSON object. But if there's any kind of differences, there won't be a bug introduced because the FIDO client just echoes back to the server exactly what it sent onto the token. And then a cookie, so that the relying party can associate all this data to a particular user. Okay, so then the relying party verifies the signature, the attestation certificate. It decides whether it'll accept this token or not. And then it stores the key handle and the public key and associates it with a user. And you'll see that authentication is very similar, except in this case, the relying party sends also a key handle because it knows which user this is. So it sends a challenge, an application ID, and a key handle. The browser again verifies that the origin is part of the application ID, constructs the client data as before, and sends the request off to the U2F token. The U2F token verifies a user touch, extracts or looks at the key handle, looks up the corresponding private key, verifies that this key handle was indeed meant for this application ID. This is how origin separation is done. Increments an internal counter to prevent cloning attacks, and then produces a signature, which it sends back along with the counter value. This is then forwarded on to the relying party, which verifies the signature, and then if everything works out, we'll set the login cookie. Okay, so arrow diagrams are great, but how do you actually use this? You might be asking yourself. So here's an example. In fact, using this is incredibly easy. This is the JavaScript API available for developers. In case you want to register a token, you would call the U2F.register command. You would provide a challenge parameter. This is something that the server sent, and an application ID, which I had just shown you as a URL, and then a callback that should be called once the browser has been able to communicate with the token and get an assertion. Once the callback is called, it contains two things: the client data, which is the challenge, the actual raw challenge that the browser sent off to the token, and the token's response. So let's peek in at those. Here, the client data, which is this top bubble, this is the raw JSON object which was sent as the challenge to the token. It said that this is a register command. Here's the challenge. This blob, which says CID public key, is the fingerprint of the TLS channel. And if you're curious about what exactly that is, you can either contact me and I will be happy to point you at the specification, but it's basically, or you can look it up yourself, but it's basically called a TLS channel ID. And then finally, origin for which this request is being made. Here, accounts.google.com. Looking at the response, it's a structured byte array. It contains the public key, the key handle, and this is the key handle is expressed as first a byte indicating the key handle length, and then the actual key handle, and it's up to the authenticator manufacturer how they want to express this key handle. the attestation certificate, which is an X509 cert, and the signature. And the signature, of course, is over the over several things. One is the application ID. Here it's 32 bytes as an application parameter. This is actually a digest of the application ID. This is a digest of the challenge. This is the key handle, and this is the public key. And of course, this is all just a signature. All right. The sign command is very similar, except now instead of just providing the challenge and the key and the application ID, the developer also must provide a key handle. The callback function is also very similar. It again carries the client data, which is the raw data that was sent to the token, and the token's response. The client data here again says, as you might have guessed, this is an authenticate command. This is the challenge. This is the fingerprint of the TLS connection, the CID public key, and again the origin. The response is again a structured byte array, with the first byte indicating whether there was a user presence or not, a counter, 4 bytes worth of a counter, and a signature, which again is structured in a particular way. So these JavaScript APIs are pretty simple to use. They're pretty straightforward. There's really not much here. All right. Let's see. Let me check to see if there's any questions before I go forward. All right. No questions. So let me then go ahead. All right, hopefully you saw that this was pretty simple to use, and there's plenty of advantages to actually doing this.
Sorry,
so
Alexei.
What if you actually want to accept U2F? Yes.
Alexei, it turns out that people are using, and probably quite reasonably, they're using the question facility that's in GoToWebinar rather than the chat room. So in fact, there are some questions. Let me read some of them out to you.
Okay.
Probably a really important one to have gotten earlier would be, does the U2F key need any client-side software to be installed, or does the browser go ahead and read it off the USB device?
It's a great question. The currently the Chrome browser comes with, well, you can download an extension with the Chrome browser that will support this. However, we are building this support into the Chrome browser core, and we expect this to ship sometime in the next several months. Basically, this support will be part of the browser, and in fact, I think you don't even need currently to use an extension if you want to do this with Google. But if you want to do this with anybody else other than Google, you do need to have an extension installed. But this will go away very soon.
Was the public key of the token sent to the server in advance of the authentication challenge?
The public key of the token is stored during the registration phase. So let me go back here. Right. So yes. So the this diagram shows the 3 phases, both for registration and for authentication. During the first time that the server sees the token's public key is during registration. However, and that's right here. So this is the diagram for registration. However, for authentication, there's no need to have the public key be sent because the server already knows the public key at this point.
When I log into Google with U2F, I don't need the U2F plugin for Chrome. Other sites require the plugin. Why?
That's a great question. And the answer is that the Chrome team is very specific about the process by which we make APIs available to third-party developers. There's a very long process to get this done in a very, very high-quality bar, and we're going through that process. So underneath the hood, all the support is there. It's just we have to dot the I's and cross the T's before we make that fully available to everybody. So meanwhile, we have released this extension. But as I mentioned, in the next couple of months, as soon as we're able to dot the I's and cross the T's, this support will be available to all websites, not just Google, without an extension.
What is the cost of such a U2F device?
Wonderful question. So let's see here if I can. So if you go to Amazon.com as an example, I think there's also other avenues for this being sold. You can see a number of U2F security keys by several vendors, and they have different features. So for example, here is a token produced by Yubico. This one is $17.99. Another token is produced by PlugUp. This is $5.99, and they work slightly differently. There's also a more expensive version of these as well, which has additional features. So there's a wide variety of both tokens and price ranges depending on what it is you want.
This is all fine for desktop and Chrome, but what does the future hold in terms of mobile devices?
Great question. I have, let's see here. So I have a slide here I was going to go to, but I might as well get to that now. We are currently working on support for BLE and NFC, and in fact, if you were all in this room with me, well, I guess you wouldn't fit. But other than that, I would show you a demo where we have this working over NFC. So you would just take your maybe I even can turn on a webcam. Here's an experiment. If everything breaks, I'm sorry. I know we've never tried to use a webcam here before. Are you able to see me?
Yes.
Great. Okay. So here I have a device, an Android device. Here I have an example U2F token, and in fact, to authenticate in the browser on one of these devices, I have support for this token to just touch the back, and that's it. Using NFC, this will basically sign an assertion. Let me turn off that. Okay, there we go. And this is being standardized as we speak. Again, this specification is not quite yet ready, but if you are interested in either building one of these or having input on how that should work, please come join FIDO and have input. But we expect that the specification will be released soon. Similarly, we're working on Bluetooth Low Energy so that we can be compatible with devices that don't have an NFC chip. For example, on iOS, we don't currently have access to NFC APIs, but we do have access to BLE APIs. So that's coming down the line. Similarly, even for desktops, in some cases, the USB drives might be full. It might be just more convenient to use some kind of wireless protocol. Again, their BLE will be very handy, and all of that is in progress as we speak.
If the user wants to keep a second UBS token in case the first is lost, does the relying party need to maintain two public keys for the same user?
Correct. Indeed, you do. Let me pause the screen here for a second and try to so that I can get to a screen and show you something here. Just a second. I'm navigating to a web page which will show you here. Sorry, it's going to take me just a second. Okay, so this is the current. Are you able to see my screen again, Donald?
I beg your pardon?
Are you able to see my screen again?
Yes.
Perfect. So here you see the security keys, the U2F security keys that I have registered for my personal account in my personal, Google Gmail account. And you see that there are 3 keys, last of which I used in front of you just a couple minutes ago. In this particular case, the server does need to maintain all my keys 3, but it's really up to the server. I think that consumers will want to have multiple keys in case one is lost or one just lives in the USB drive of their computer. And in fact, the protocol supports this, and we do send multiple key handles at a time, basically, to the tokens. Yeah.
Can authentication flow be combined with OAuth flows to issue OAuth tokens?
So we have not. Well, we have tried to keep the U2F flow very self-contained, so that it's very simple to use and you can use it irrespective of anything else. You can get creative into how you combine it with other flows. I don't know that we have specifically thought about it combining it with OAuth flows. However, you can imagine that a user authentication flow might begin with an OAuth flow and then conclude with a U2F flow. In case the relying party wants more proof that it's the actual user. I think combining them into one flow is probably possible. I don't know that we've heard a need of doing this from any of the number of people that have been involved. If there is a need, we should talk and we should see if we can figure this out. I think it would be interesting. Yeah.
What about device cloning? Current tokens don't store private keys on board, but encrypt it and send it to a relay party.
Correct. They do. That's right. That's not mandated by the spec, however. That's just an implementation detail that the token vendors have decided to use. We believe it's secure. And one reason is that the token does have some permanent storage, and it uses that permanent storage to store a counter, and that counter value is what we use to look for and prevent device cloning.
What happens if I change my domain? Would my users need to register their key a second time?
This is a good question, changing a domain. So it depends how much you change your domain. There are certain limitations on the kind of domains that the application ID can span. For security reasons, I believe we said that you can change your subdomain, but you can't change your global domain. I believe if in the way that the current spec is implemented, if you change your global domain from, I don't know, apple.com to orange.com, then you would have to have your users register for security reasons. However, if you change your domain from a.apple.com to b.apple.com, then that would be okay given a specifically typed application ID.
Here's an interesting one. Why does the attestation certificate exist and the spec require that it be trusted? Is it just so the FIDO Alliance can get licensing fees from device manufacturers, or is there a technical reason?
So I personally don't know if the FIDO Alliance gets any kind of fees. Maybe Donald can answer that.
Yeah, no fees.
Okay, so there's that answer. The attestation certificate exists because there is a need for relying parties to potentially discriminate between the type of tokens it accepts and doesn't accept. The U2F protocol is open and anyone can implement it, but that means that certain type of tokens may not have as much security as other type of tokens, and as a relying party, it should be possible for relying parties to choose to accept certain type of tokens and not accept other types of tokens. So, for example, I don't know, if you're a bank, you might want to choose to accept tokens that have that are backed by a smart card, or you may choose not to do that. But that should be up to you. Furthermore, depending on you might accept all tokens, but if you trust a specific type of token less, you might want to be able to throw additional challenges at the user to make sure that it's them. If your risk engine tells you that this particular login might be kind of risky, for example, it comes from an IP address that you know has been attacking you lately. Another reason is that in case that there's ever a bad batch of tokens, for example, ones that have a bug or ones that have been known to be implemented poorly and therefore they were compromised, we need the existence of an attestation certificate to perform some kind of revocation on the relying party side. The relying party needs to say, now I don't accept these type of tokens. So that's the reason for it existing.
I've seen in documents that you can send the private key to the relying party within the key handle. How safe is this process?
We believe it's safe. And you're exactly right. The key handle is sent. The private key is wrapped inside the key handle. We believe it's safe enough to do it ourselves. So there's an answer.
Okay, what about room for storage of all the public keys?
On the server side, I'm assuming this question. I guess let me try to answer both sides of this question. If this question has to do with on the token side, it's up to the token vendor. They can either choose to have a limited number of keys, or they can do this trick that we've been sort of talking about here. This isn't exposed in the slides, but if you read into the specs, it allows the key handle again to contain the private key, and at that point, the token can store in quotation marks an infinite number of key handles or public keys. But on the server side, this is limited by the server's storage capacity.
So can a server demand a certain authentication level, trust level, i.e. prohibiting less secure U2F devices?
Sure. The U2F protocol doesn't dictate what the relying party must or must not do. It's really up to the relying party to choose the trade-off between security and usability for users. Some relying parties might say that we accept only one type of token. I think we, in general, as an ecosystem, try to discourage that and say, hey, you should, for the sake of usability, you should consider accepting more than one type of token. You should consider accepting as many tokens as you see fit. At the same point in time, it really is up to the relying party to guarantee the safety of their users. And if they believe that a particular type of token is not safe, is not secure, then they can act accordingly. It also depends on the threat model that you believe your users face. We at Google believe that our users, especially the users for which we recommend the use of U2F tokens, have a very, very strong threat model. They're seeing threats, at potentially the state level, and we believe that this protocol is secure enough to guard them against state-level attackers, even with this private key wrapping.
So we've quite a few more questions. I'd like to let you go back to the presentation, but let me ask one question which I've tried to, so somebody sent in this specific question, but I think it answers a lot of other people's questions. And it's quite simply, can you explain the relationship between U2F and UAF?
Sure. This is a good question. So the UAF is an attempt to get rid of passwords altogether. So it's the Universal Authentication Factor, I believe that's what it stands for. And there, the idea is that it's something that it's a device that is able to authenticate the user. So, for example, it's a device that has a fingerprint reader. It's a device that has a retinal scan. It's a device that does something that is able to authenticate the user, and then it goes ahead and proves that onto to the relying party. The U2F, in some sense, is a bit more grounded in the way that the systems work right now. Most systems have passwords, and so what this is saying is this is an additional check on top of passwords that does not identify the user. So all the U2F tokens that are available currently for sale, I believe, don't have any kind of fingerprint sensors. It's just a touch. So it's what you have and what you know. And the UAF approach, which eventually perhaps U2F will move towards or be absorbed into, is a bit more forward-looking, where it's the one factor that is able to identify your identity. It's something that we believe is it's the future, but it's something that it's probably going to take a little bit longer to deploy, and therefore U2F is something that you can deploy now with your current website to give a lot of security to your users.
Okay, Alexei, let's go ahead and finish with your slides, and then we'll come back to more questions.
Sounds good. Okay, so we went through all of the designs. I showed you examples of the code. I showed you a demo. So the question now is, what do you do if you want to accept these tokens? Well, you need to actually call the JavaScript APIs. Today, these JavaScript APIs are provided by the browser extension, as I mentioned. However, in the near future, they will be part of the browser core. On the server side, you need to implement the registration flow. You need to decide how you're going to handle attestation certificates, whether you're going to accept all of them, some of them, none of them. Well, I guess if you accept none of them, then this doesn't really work, so either some of them or all of them. You're going to have to verify the registration response, and you're going to have to store the public key, the key handle, and associated with the user account. And as was mentioned in the questions, this might be multiple key handles, multiple public keys. And you're going to have to implement the login flow. You're going to have to check the username and password just as you're doing now. But then on top of it, you're going to have to look up the key handle and then verify the authentication response. This means the origin, the signature, and the counter. And finally, once you do all of that, you need to go back and you need to check your account recovery flow. Because if you make your sign-in flow harder, attackers will try to go in through the back route, through the account recovery flow. And some of this is nuanced, so you might want to call in the professionals if you don't have folks in your organization who are able to do it themselves. And there's a bunch of people, both that are part of the FIDO Alliance and probably outside, who are willing to help you deploy this with your web service. What happens if you want to offer a USB U2F device? Well, you'll have to implement ECDSA P256. You're going to have to implement a counter on the device. You're going to have to decide on a key handle strategy. Do you want to wrap the private key, or do you just want to store the private key locally and associated with an application ID? You're going to have to implement the USB framing document or the framing specification. And then remember that you are not allowed to provide any responses without user presence. So you're going to have to check user presence in some way. And we currently have, I think, 2 examples of doing that. One is by touching a U2F device. There's a capacitive touch sensor, or by plugging it in and out. And I think the plug-up devices do that. The one exception where you don't have to check for user presence is a particular command that checks to see if a particular token is already registered. And this is a kind of nuanced, and I'm happy to talk with you about it offline. But again, it's safe, but it's there for a particular usability reason. Okay. So people were asking about wireless protocols, NFC, BLE, etc. If you are interested in offering one of these or supporting this, again, please come join FIDO. We would love to have your input. We currently have a specification in the works and a couple of prototypes. If you want a different form factor other than USB, Bluetooth, NFC, come talk to us. Come join FIDO and let us know what you think. I think people will be very excited to hear what your ideas are and try to move forward on that.
Okay, let's go back to some questions, if that's okay with you, Alexei.
Sure.
Here's one. How did the spec choose NIST or NIST P-256 for EC keys? Have you given any thought to changing it in future versions after DJB research at safecurves.cr.yp.to? So somebody must have found some kind of a flaw with the NIST standard or spec.
Right. So we follow the latest developments in cryptography very closely. We have a bunch of cryptographers here at Google, and there's a bunch of cryptographers also that are part of FIDO. We believe that the NIST P256 curve is the best for currently for a number of reasons. We believe that it is secure enough at the present. We believe that it has also certain features which make it nice for implementation. It has I'm not a lawyer, so I'm not saying this as a lawyer at all, but as you know, there are, as I'm sure many of you know, there are certain patent implications to a certain type of curves. We believe that this particular curve does not have a certain type of encumbrances that others might. So for a variety of reasons, this curve was chosen. I think if you're interested in more specifics and have some concerns, please chat with me offline, and we can talk about the specific details.
How a relying party knows what type of token is used? Any ID? But if this is ID, then someone may copy this ID to own unsecured token. That's not very clear, but do you get the drift of it? How does the relying party know what type of token is used?
Oh, let's see. This question might be asking several things, and I'll maybe try to answer all of them, and hopefully I'll answer the thing that the question was actually asking. During the registration flow, the token provides a attestation certificate which identifies which type of token this is, and this is done in a batch, meaning that it's not uniquely identifiable. I believe the current specification says, I want to say 1,500 is the minimum size of a batch. So, but it could be larger. I don't remember off the top of my head. But basically, it says what type of token it is, but it doesn't say whose token it is. It's not a unique ID that you can track. And the token also yields a key handle, but this key handle is for a particular origin. So another origin will see a different key handle, a different public key, a different ID. During the sign-in flow, during the authentication flow, it is actually the server which specifies which token it is. By that time, it already knows the token because it's doing the U2F authentication for a particular user. Remember, this is done after the user types their username and password. At that point, the server knows the key handle because it has it stored in a database in the public key as well. However, if you lose the token and the token is picked up in the parking lot, there's really nothing that you can do to ask the token who its owner was. The best you can do is if you can somehow guess a key handle, which would be pretty difficult. You would have to know the user. It would have to be a targeted attack where the username password is known to the attacker, and then the attacker would have to go to the particular website that they believe this token is registered with. But that's a very serious attack. This means that you're being pursued by an entity physically in your physical space, and we'd hope that the user, at that point, if they're facing that kind of adversaries, would be able to go to the website and unregister their U2F token before the adversary was able to use it. But again, this is a threat model which we believe is not something that most of the users will be facing.
Is there any reference U2F Java card applet available?
Yes. Actually, one thing that I wanted to mention, and let's see. if I can pull it up here, GitHub. In fact, if you go to this GitHub page, here you'll see that all the source code is open source. There's reference code, there's a demo, there's an extension. The reference code, I believe, is in Java. There's Java here, and you can go ahead and look in that code and use it freely. It's available online and released by us. I believe some of the other vendors have also released some code that might be more Java card specific.
So I'd like to take the opportunity of answering some of the questions. Quite a few people have been talking about license fees and so on. FIDO is not a money-making institution. It's a standards body, and where there is no license fee going forward. There will be fees associated with certification, one-time fees, but other than that, there's no, it's a fee-free license going forward for anybody who wants to implement anything. There have been some questions about joining the Alliance. The membership level that allows you to participate in the discussions and voting on the standards and so on is the sponsor level. It is $25,000 a year. There's another level called the associate level, which for small companies is only $1,000 a year. But the actual capabilities, if you like, of an associate member are fairly limited. You can't participate in the voting at the technical working groups. In fact, you almost certainly won't be able to participate in the technical working groups. So sponsor level is the level to aim for if you want to actually influence the standards, or if you want to go to all the meetings and have the opportunity to discuss the details with people like Alexei and the others. We have a couple of minutes. Alexei, is there anything else that you'd like to talk to?
I don't think so. I think this is pretty much it.
While you're thinking, there's a question here. It says the membership fee, and this is for associates, although he doesn't say this. The membership goes from 1K for 100 or less employees and then jumps to 15K for 101 or more. For a small company, that seems to be a huge jump, like with 101 employees. Well, the reason that we raised the associate fee for companies of 100 employees and more is that some very large companies were joining the Alliance at the associate level. And I mean, we do need to run seminars, we need to run webinars like this. We have a small, not a very big, but a small staff that has to be paid. We have the meetings to run and so on. So obviously we can't do this on no money at all. And if everybody joins at $1,000 a year, we just can't function. It's as simple as that. My answer is crude, but it's true.
So Donald, I guess one clarifying question. So if I'm a web service and I want to support this on my website, do I need to pay anything?
No, not necessarily. If you're not interested in the technology, you can buy it from one of the people who are members, almost certainly, who have implemented solutions.
Okay. I don't have any questions.
Okay. Let's see if I can find. There are a lot of questions here. Does the automatic token response mode, no touch required, raise a privacy issue identifying the user to any page using the JS API?
Right. So that's right. So that's the no touch required. That's with one exception here, the last bullet point. It doesn't, because it's meant to. So that information is not forwarded on to the JavaScript API. That's handled all within the FIDO client, and it's basically done for the following reason. If you have multiple tokens plugged in, we want to make sure that we blink the right token, for example. However, again, the actual details are sort of nuanced, but the high-level picture is no. The high-level answer is no, it doesn't. That information is never released to the JavaScript API. It's just handled internally by the FIDO client.
Yeah, I have another one here from somebody who's asked the question twice and obviously needs an answer. And I'm a little bit confused by the question, but Alexei, you may be able to help. It is important to know the price of an attestation certificate. Please answer this.
One more time, can you read the question?
It's important to know the price, and I'm emphasizing it because it's in capital letters, of an attestation certificate.
I don't think there is a price of an attestation certificate. So let's I guess be clear here. I'm not an authentication or authenticator manufacturer. The attestation certificate is something that the authenticator manufacturer needs to figure out. There's no mandate for the attestation certificate to actually go, to be made by anybody. It's not a web TLS PKI kind of situation where there's a certain set of root certificate or root certificate authorities. There is no such root certificate authority list for U2F. In fact, you could manufacture a fresh attestation certificate every single time you register, right? I don't know if you necessarily want to do that, but you could do that, and you could say that it chains back to Acme Corporation. This thing could be completely fake. The other hand, though, is remember that the relying party can choose to accept or not to accept attestation certificates. So, it's kind of, I don't know how to say this. You can choose not to have an attestation certificate at all, or a bogus one, and the relying party will then make its own decision whether it trusts this token or doesn't trust this token. Or you can choose to have an attestation certificate that says that this is a smart card made by a known smart card manufacturer, and in that case you'll have to go talk to the smart card manufacturers and decide, negotiate the price for an attestation certificate. There's no real one answer here at all. Or you could publish your attestation. You could publish the root of your attestation widely on the web and say, this is what this is. This is a custom smart card. And again, the relying parties will then choose to accept this or not to accept this. There's not one answer here.
So there have been a lot of questions about UAF, and I've not bothered to ask them, but knowing that a lot of people are really interested in getting an update as to what's going on there, we will have a UAF webinar on Monday, December the 8th. So that's in less than 2 weeks, I think. It'll be at 9 a.m. Pacific rather than 9:30. And I did send out an email. If anybody has a problem, hasn't gotten an email, or wants more information, don't hesitate to email me. Another question is, can we capture these questions and answer them offline, or at least publish a kind of a Q&A based on them? And the answer to that is I don't know. I can see you can capture the chat room, which is why I wanted to use it. But I don't see any way of printing or saving the question list. But I will investigate that before I shut the webinar down. We have recorded the webinar, so if any of your colleagues need to listen to it, we will make that available. If you watch the website, I'll also try and send an email to those of you who registered and pointing to it. It'll be a couple of days, sometime next week. Alexei, thank you very much for an excellent presentation. I'm sure everybody agrees with me. And in the meantime, between now and the UAF webinar, everybody have a great Thanksgiving and stay safe.